Hello and welcome to the video for section 2.5, which is on reasoning in algebra and geometry. The first thing we have to do is go over several properties, and remember that you're going to need to write these properties down on that little cheat sheet that I gave you, because you will need them for when we're solving these proofs towards the end of this section. So properties of equality, and a lot of these we've learned before. You just might not know the names of some of them. We've talked about them, we just haven't written them out exactly like this. So the addition property, if A equals B, then A plus C would equal B plus C. A pretty common sense concept, but there is a property for it. Subtraction property, if A equals B, then if you take A minus C, that would equal B minus C. Well, obviously, if A and B are equal, if you subtract the same number from both, it's going to be the same. Multiplication property of equality, if A equals B, then A times C is going to equal B times C. So these three right here are all the same concept, okay? This one changes a little bit because it's division, and remember that when you divide, you can't divide by 0, right? So if C, you don't want to have C equal to 0. So if A equals B, and C is not 0, then A divided by C would equal B divided by C. Remember, you can't have a 0 on the bottom of a fraction, so that it's not even a real number. Reflexive property, they're just saying that A equals A, okay? It's like a reflection. You want to think about it that way. Symmetric property of equality, if A equals B, then B equals A, and there they're flipping it, okay? But it really just means the same thing. Transitive property, if A equals B and B equals C, then A must also equal C. Okay, let me say that again. If A equals B and B is equal to C, then A would be equal to C. Substitution property, if A equals B, then B can replace A in any expression. And that's something we've been using all along. You just need to know the name for it as we're going through the proofs. Distributive property, we've used this many times in algebra in 7th and 8th grade. You use multiplication to distribute the number on the outside of parentheses to each number on the inside. And I have a little example here, or I have it drawn out so that we remember what that actually means. So if you have A times the sum of B plus C in parentheses, it really just means that you take A times B and then go back and take A times C. And so your answer would be AB plus AC. How did we know it was a plus there? Because there was a plus here and it was all positives. And so here when we're doing this, this is a very simplified, maybe the beginning steps of a proof, I guess I should call it. Having a reason for each step is kind of what we're going to do with the proofs also. This is a little different way to show it, but you're basically showing what rule goes with each step, okay? The reason that justifies each step. So 1/2 x minus 5 equals 10, that's given. That's just the problem that I started with. And so then when I go to the next step and it says 2 times 1/2 x minus 5 equals 20, what did I do there? How did I get there from my first step? I used the multiplication property of equality. I took both sides times 2, and I ended up with the same answer, okay? Then the next step, I go x minus 10 equals 20. How did I get that? I used the distributive property. I took 2 times, right here, 2 times 1/2 is 1, so it's just an x. And then 2 times 5 is 10, and it's a minus there, so it's a minus 10. And the 20 I just brought down. How did I get then the answer, which is x equals 30? I used the addition property of equality. I added 10 to this side, which means I also have to add 10 to this side. And we also have properties of congruence, and so we need to go through all of these. The reflexive property of congruence. If segment AB is congruent to segment AB, angle A is congruent to angle A. Okay, it's kind of just like that other reflexive property. If you have the same segment, it's going to equal the same segment. Symmetric property, if segment AB is congruent to CD, then CD is congruent to AB. Remember on the symmetric property up here, it was very similar, right? You flip them around. If AB equals CD, then CD equals AB. Up here we did if A equals B, then B equals A. Same thing. You're flipping it around. You can also do it with angles. If A is congruent to B, then guess what? Angle B is also congruent to angle A. Again, pretty common sense, but you need to understand these rules as we go through the proofs here in a minute. Transitive property, if AB is congruent to CD and CD is congruent to EF, then AB would be congruent to EF. So we're using the same thing we did with those equality properties. We're just using angles and segments now. So if angle A is congruent to angle B and angle B is congruent to angle C, then angle A would also be congruent to angle C. If angle B is congruent to angle A and B is congruent to angle C, then A and C would also have to be equal. So here we're going to name the property of equality or congruence that justifies going from the first step to the second step. So ignore that I already have the answer here. Look at the problem. 2x plus 1 equals 7. How did I get to the next step, which is 2x equals 6? I subtracted 1 from both sides. I'm not showing the work, I'm just showing the steps. What property shows that? The subtraction property of equality, that if I subtract the same number from both sides, I end up with the same answer. So a proof, which is the big to-do of this whole section here, it's the big picture. It's a convincing statement that uses deductive reasoning to show why a conjecture is true. And you have to go step by step through the proof. And you have to justify each step and each statement that is given. You have to prove it, in other words, using these rules, these postulates, the properties. So a two-column proof, it's exactly what it sounds like it would be. It's a column that's written in two, or excuse me, a proof that's written in two columns. It lists each statement on the left, and the justification or the reason for each statement is on the right side of the column. And each statement that you make has to follow logically from the steps before it. You can't skip steps. So you have to go from what they give you and try to prove what they're asking you to prove using a set of steps. And so here I have filled in part of it for you, and then we're going to go through the rest of it together. So we're going to fill in the missing statements or reasons for the two-column proof, and then, so I have some statements missing and some reasons missing, and we have to go through and fill in the rest of this with what's given. So given, this has already been proven, this is given, okay? C is the midpoint of AD, and here's my picture. So C is in the middle of AD, and I'm telling you that from A to C is 4x, and C to D is 2x plus 12, and so we should already be able to go through and do the work, right, and figure out what the answer is based on what we already know, setting those two things equal to each other if they say that they're congruent, and that is the midpoint. But this is written a little different here. So let me go back to, so I can type here. So the first step, it says C is the midpoint of AD. Well, how did I know that? Because they gave it to me. So over here you write in given. How did I get to this next step? That AC is congruent to CD. How do I know that? How do I know AC is congruent to CD? Okay, what postulate, rule, property, statement, how can I prove that? I know it because a midpoint divides segments into two equal parts. That's how I know it. Okay? That is my reason for it. My justification for saying that AC is congruent to CD. Okay? The next part is all done for you, but look at what it says. It says AC equals CD. Okay? So, well, how do we know that? Congruent segments have equal lengths. Okay, so here I said it was congruent, and now here I'm saying it's equal. So I'm really just writing this in another way. Okay? Then, how do I know that 4x equals 2x plus 12? Like, what's my reason for that? How do I know that? What am I going to type here? What did I use there? I used the substitution property, okay, to do that. I substituted 4x in for AC because that's what it says it is right here. And I substituted 2x plus 12 in for CD because that is what it says. So I use the substitution property. Okay, to get from there then, how do I know what's next? How do I get to the next step? How do I know what my next step is going to be? Well, I'm going to have to do some work here, right? I need to combine some terms, moving things around. And so if I subtract the 2x from right here and move it over here, and I'm also subtracting 2x right there, what am I doing? I will have 2x equals 12. That's what I'll have left. Okay? And once I solve this one step and I move it to here, how did I do that? I used the subtraction property of equality. I subtracted 2x from here and 2x from here, leaving me with this. Now the next thing that is written is a statement, and it says x equals 6. Well, how did I know that? I solved this, right? But what did I use to solve it? What is that called? What did I do? It is the division property of equality. If you divide one side by the same number, divide both sides by the same number, you end up with the same answer. So on some of the proofs that we're going to do, it'll be like this, where part of it's missing, part of it's given. And I probably will also have you do one where nothing is given, and so you have to figure it out from beginning to end. And so again, make sure that you have your sheet filled out with all of these postulates, all these rules, properties, so that when you go to do your proofs, you will have what you need in front of you on your little cheat sheet that I gave you. Bring this information with you, and I will see you tomorrow. Have a good night.